Okay, here we go. Here's a little video I just made on finding the average rate of change for a function across a given interval of x's. So there's kind of like two slides coming up at you. The first one is more or less just a review of finding slope in general, just kind of straightforward between 2 points. And then after that is an example of finding a little bit more complex example where you have to actually use the average rate of change given two x values. Okay, so here we have a picture of Mount Rainier. And so let's just say that we're going to climb up this left side here that has a nice consistent slope. And so let's just say we're starting at the bottom and ending at the top. And we can see that that's a nice consistent slope. Okay, let's go ahead and label it with some points that are nice and easy to use. So let's just say that we are starting at point 0 for our x, and I'm going to move horizontally to the right, like this distance right here. Let's say about 4 kilometers. So I'm going to go from 0 to 4 to be a movement of 4 kilometers. Okay, let's talk about our y's, which are our heights. So we're going to start, base camp for this climb is about 6,000 feet. I'm just going to put a 6 there to make it nice, easy points to work with. And it tops out at right about 14,000 feet. So we'll just call it 14 right there. Now, if I was going to find the slope, I'm just going to use the slope formula, which is the difference in my y's over the difference in my x's. So let's go ahead and do this here. I'm going to set it up. I like to just put my minuses in right off the bat so I don't mess anything up there. Okay, let's go ahead and find my y's. So my y's are going to be the second values right there. I'm going to do the second y minus the first y. Okay, next I need my x's on the bottom. So there's my x's on the bottom. Okay, now notice how I chose a direction. Notice how I did my second y and then subtracted my first y. So it doesn't really matter which direction you choose, you just have to stay consistent. So I now have to use that same direction for my x's. So I'm going to go 4 minus 0. All right, let's see where we end up here. So I have 14 minus 6, that would be 8. And then 4 minus 0, that would be 4. And then I'm going to get out 2 here for my slope. And so since my slope is 2, you might even think 2 over 1. What that means is I'm going to rise up 2,000 feet for every 1 kilometer I move horizontally. Okay, let's go ahead and talk about a question like this now. So here I have a function where I want to find the average rate of change across a specific interval here. Now note that this is an interval. These are both x values. This is not a coordinate point. It is not an x and a y, but it's actually from the first x value of 3 to another, again, x value of 5. Okay, let's go ahead and think about what this is actually asking. So when we look at this function, we know that that's a parabola, upwards facing, and we know what that's going to look like approximately. But for right now, to get a better idea of what these types of questions are asking as a whole, I'm going to draw kind of an exaggerated polynomial that goes up and down quite a bit. And let's go ahead and think about this as maybe a mountain range that we're hiking. And so this is very different than Mount Rainier. We're going to go up and then hit a peak and then come down and up and hit a peak and then come down. And maybe we want to stop and take a little break up there. Okay, let's kind of think about what my average rate of change is, or average slope, or average steepness. Let's go ahead and just start at this first peak and end at this last peak. Now obviously my slope is going to change a lot. So maybe right here it's steep and going down. Right here it's steep and going up. And it's changing a lot across the whole thing. But what I'm really interested in here is I'm interested in the average. So if I could go straight across. Now, we were saying earlier that we were actually given two x values. So those two x values are like the first coordinates of the 2 points. So I have those two x values. So what do we need here? What I need is my corresponding y values. Once I have those corresponding y values, I can find the slope just like I did on the previous slide with that volcano, with that Mount Rainier problem. So all I have to do is find the y values. And the way that I can do that is by plugging in those y values into my function right here. So that's what we're going to do. Okay, so I went ahead and just made myself a little bit more space. Let's go ahead and use this function right here, and I'm just going to bring it down and rewrite the same thing, but I'm just going to plug in 3 instead of x. So it says x squared, so let's go 3 squared, plus 6x, so I'm going to go 6 times 3, plus 2. And let's just check out what I did right there. So what I did is I plugged in this 3 for x and x, and that's it. Okay, let's see what I get there. So we've got a 9, an 18, and a 2. Okay, so 9, 18, that's going to be 27, 29. So now I've got that first point done. All right, let's go ahead and check out this second point now. So now if I check out my new x value of 5, and I'm going to plug that in for my x's right there and right there. So instead of x squared plus 6x plus 2, I'm going to go 5 squared plus 6x, well that's going to be 6 times 5 plus 2. Okay, I'm at a 25, I'm at a 30, and a 2. Okay, 30, 45, 55, and then 57. All right, and now what I have is I have my two corresponding points. So let's go ahead and find the slope now. How do we find the slope again? That was the difference in my y's over the difference in my x's. Okay, let's go ahead and maybe use purple to find my y values. And I'm just going to pick a direction. I could go either direction, but we could just always stick with going right to left. So let's go 57 minus 29. Okay, I'm going to do the same thing for my x's. So here's my two x's. Now I actually don't have a choice this time. I have to stay consistent with what I did before. So I'm going to go 5 minus 3. All right. Okay, we might as well do the easy one first. 5 minus 3 is 2. And if I'm looking at the difference on these guys, 29 to 59 would be 30. So it's going to be 2 less than 30. So we're looking at 28. Okay, that's going to be 28 over 2, or 14 over 1, or I guess just 14. And what did I find here? I found my average rate of change for that function across this interval.